So we were doing about introduction to operating system. So under that, first of all, we saw the definition of operating system. So this is a textbook definition. What we saw, wherein we said operating system is a program which acts as a intermediary between the user of the computer and the hardware. So that is what we saw, right? So that we saw in the first class. Then we also saw the purpose of operating system. So when you say purpose, so what is the purpose of operating system? Create an environment wherein the user can execute his program easily. Okay, that is what here we are saying. Provide an environment in which user can execute in a convenient and efficient manner. So user should be able to do his job easily. So that is the purpose of operating system. So under this, the next point what we saw was computer system architecture, under which we saw the four components of the computer system. So we spoke about hardware, operating system, application program, and the users. So this was a diagram what we had seen. So all this were already done in the previous session. Yes or no?
Yes, ma'am.
Okay. So I'll just briefly I will be saying. So after this, we saw about the different view or viewpoint of operating system. So it was under the viewpoint from user view, and the next one was from the system view. So under the user view, we said operating system or your computer. We can say it as a user is sitting in front of a system, that is from the user point of view, that is PC. And next one is he is connected to the terminal, which is connected to the mainframe computer. Next one, workstation. Next we saw was PDA, and finally we saw was embedded system, wherein we said the user interface is limited, right? And after that we saw about the system view. So computer system, or you can also say OS in terms of system view. We can say OS is a resource allocator, and OS can also be called as a control program. So when you say resource allocator, what did we say under this? We can say operating system as a resource allocator. So, what is the task of operating system? So, there might be many requests coming in for some device. Now, you are typing something, you want to print that document. So, what is the meaning of that? You are asking for a resource. What is that resource? The printer, right? So it can happen that there might be systems connected to the network. It might be that n number of users are asking for the same resource. In such case, what happens? A conflict arises, right? So out of that n number of users, who should be given the control of that resource? So that is the decision that is taken by the operating system. So for that purpose, you can say operating system as a resource allocator. And next one we saw was operating system is a control program. So when you say control program, operating system makes sure that your program executes without that is, you can say, it prevents errors and improper use of computer. So for that purpose, you can say operating system as a control program. Okay. And the next point what we saw was the next topic, it is, that is operating system operation. So we were doing this particular topic. Under this we had already seen about dual mode operation. So what did we say in dual mode operation? What is the purpose of going in for dual mode operation? So we want to protect, that is, any unauthorized, or you can say the term that is used in your textbook is they are saying as errant users, okay, or an unauthorized user. So we need to protect our operating system from these users. So how we can do this? So that can be done by using this dual mode operation. So some set of instructions can be executed only in the kernel mode. So such kind of instruction we can call it as privilege instruction, which is related to the operating system. And any user application related process, so that will be executed in the user process. So to keep track of this, we have a bit that is called as mode bit. So that is set in the hardware. So if the mode bit is equal to 0, that means you are in the kernel mode. If the mode bit is equal to 1, that means you are in the user mode. So what did we say? Initially we will be in the kernel mode and your desktop will be loaded, right? So initially the booting process happens, and if all the devices connected to your system is working fine, Then the operating system is loaded. Operating system is loaded, that's nothing but your desktop is loaded. So once the desktop is loaded, so till here you will be in the kernel mode. Now you click on some icon, that means you are going into the user mode, right? So that is what we said here. From the user mode you can shift to the kernel mode, and from the kernel mode, that is here we you can see here user process is executing. Diagram, just see this diagram. User process is executing and user is calling some system call. So system call is nothing but these are the functions only, but which is associated with the kernel. Okay, so that time what happens, you will be shifted from the user mode to the kernel mode. That time just see the mode bit. In the user process your or user mode, your mode bit was set to 1. When you jump into the kernel mode, then the mode bit is set to 0. So this is the main thing what you should remember. In the user mode, your mode bit is 1. In the kernel mode, mode bit is 0. Okay, then so in the kernel mode, any privilege instruction you want to execute. Privilege instruction means what? If any unauthorized user try to access this privilege instruction, it can happen that your operating system, that is he might try to change some data in your operating system, which might result in your OS to crash. So for that purpose we have to protect our operating system. So for that purpose this dual mode operation is there. Okay, so we continue executing the system call in the kernel mode. Once after you complete the execution, then again you are going to return back to the user mode. So that time what happens, the mode bit will be changed to 1, which in other way you can say you have written back in, you have returned to the user mode. So this is what happens in the dual mode operation. The purpose of using this dual mode is to protect our operating system from unauthorized, or you can also say errant users. Okay, so what happens in this case, the privilege instruction will be stored in the kernel mode. That is, the instruction that are present in the kernel mode, you can call it as privilege instruction. So if you want to execute those instructions, then we have to be in the kernel mode, wherein the mode bit will be set to 0. Okay, so last class we had seen till here, right? Yes or no?
Yes, ma'am.
Okay.
Yes, ma'am. Yes, ma'am. Yes, ma'am. Yes, ma'am.
Okay. So now we will go to the next part under your um, operating system operations. The next topic, that is timer. Okay. So in simple words, if you say what is this timer? Why are we using the timers? Anybody? So anybody here has already set a timer saying that 11 o'clock she has to stop, otherwise I'm going to say that time is up. Anybody? Am I audible? Yes.
Yes, ma'am.
Okay.
Yes, ma'am.
What is the
Yes, ma'am.
purpose of timer? If there is no timing, then what happens? Now there is no timetable given to you. Is a timetable given to you? Today's timetable?
Yes, ma'am. Yes, ma'am.
What time is the next hour?
At
What time?
11.
11 o'clock.
11 to 12.
11 to 12. Okay. So if I am engaging past 11, then what you all will do? If I'm engaging till 11:15 or 11:30, or if I'm just crossing 11, what you will do? You all will sit quietly.
We are telling that ma'am is waiting.
Yes, you will tell that, right? So why are you telling that? Because the time slot is given to you all, right?
Yes, ma'am. Yes, ma'am.
Yes. Yes. Same thing here also. We must prevent the user program from getting into an infinite loop. What do you mean by infinite loop? Are you going to come out of the program, or continuously you will be looping in the program?
Continuously looping in the program.
Yes. Do you prefer to have that in your program?
No, ma'am.
No, right? So same thing here, the same concept we are using. We don't want, there might be some program wherein the user is stuck. That is, he might be stuck in an infinite loop, or in some cases, not calling the system service, or you can say never returning the control to the operating system. We might come across such kind of situation wherein the control is never returned back to the operating system. We don't want to have such kind of situation. So to avoid that, we are using what is called as timers. Okay, so why do we use timer? Timer is used to avoid some situation wherein the user might enter into an infinite loop. We don't want that to happen. So to avoid that, we are using timers. Okay. So to accomplish this, we use timer. Timer can be set to interrupt the computer after the specified period. That is, now our situation only you assume. So the time slot given to you for this particular hour is 10 to 11. So if I'm crossing 11, then what happens from your end? The timer is set here for what? Timer is set from 10 to 11. If I'm crossing 11, then you all will say that time is up, right? So same thing here. We want to avoid the situation wherein the programmer or a user, we don't want a situation wherein he will be in an infinite loop. So for that purpose, timer is set. So timer can be set to interrupt the computer after a specified period. So here in our case, for this particular class, if you say the timer is set for 1 hour, that is from 10 to 11, right? Same thing can happen in system also. Okay, so that is about your timer. So the period can be fixed, that is example 1 by 60 second, or it can be variable for 1 millisecond to 1 second. So what we are telling, this timer can be fixed, that is this much time only, or you can vary that. So some here and there saying that from 10 to 11. So this might be from 11, you can cross to 11:05, 11:10, like that, some variable thing. Okay, so how we can do this? Here you can see here, operating system is going to set a counter. Every time the clock ticks, the counter is decremented. So now what we'll say, the simple technique we can say here is, um, we'll initialize a counter with the amount of time that a program is allowed to run. So suppose your program is with the 7-minute time limit. Okay, then in that case, we can set the counter. Am I connected, guys?
Yes, ma'am.
Okay,
Yes, ma'am.
okay.
Yes, ma'am.
So I'm connecting through the hotspot. So please tell me if I'm not, if I'm disconnected, please text me, okay, in WhatsApp. Okay, we'll come back.
Okay, ma'am.
So we were saying that suppose our program should be executed for 7 minutes. Suppose we say like that, then we will initialize the counter with the value as 420. That is 420 is nothing but 420 seconds. Okay. So every second the timer interrupts and the counter will be decremented by 1. Okay, so what we are telling, suppose our program should be executed for 7 minutes, then what we will do, we will use a counter which will be initialized to 420. 420 here is nothing but seconds, 420 seconds for 7 minutes. Okay, so every second what happens, the timer, the counter will be decremented by 1. Okay, so as long as a counter is positive, control is written to the user program. When the counter becomes negative, the operating system terminates the program. That is how you can come out of the program. Okay, so when the counter reaches 0, an interrupt will occur. That is nothing but you can say you are terminated from that particular program and the control is written back to the operating system. So this is how what you have to say for the timer. So what is the purpose of timer? Timers can be used to avoid the situation like a user might enter into an infinite loop. So to avoid all those, we can use timers. So what you're doing in timer, we are using a counter. We will initialize the counter with some value. So in the exam, you can write this example only. Suppose we have a program which takes 7 minutes to execute. Then we will initialize the counter to 420 seconds. So every second what happens, the counter will be decremented. Okay. And at one point of time when the counter reaches 0, then what happens? An interrupt occurs. The interrupt, what does it do? It is going to send the control back to the operating system. So this is about your operating system operations. Did you understand this?
Yes, ma'am.
So this question has been asked
Yes, ma'am.
many a times. They have
Yes,
asked
ma'am.
about dual mode operation. Okay, they have asked this particular question many a times, but learn about the timers also. They can ask as a whole question, one full question, that is operating system operations. So under dual mode you just have to draw this diagram and explain about the mode bit and the different modes, that is user mode and the kernel mode. So what you're going to say, so whatever I'm telling here, you just understand as a story, okay? Because if you see this textbook, you have lot of contents. So learning all those, you might find it difficult. So instead, whatever I'm telling, you listen it as a story. Then you're going to write it in your own words. Am I clear?
Ma'am.
Okay.
Yes, ma'am.
So under
Yes, ma'am.
dual mode of operation, what you're going to say, initially will be in the kernel mode when the operating system is loading, and once the desktop is loaded and you click on some icon, that is your application program, you're shifting to your application program, that time will be shifted to the user mode. Okay. So to differentiate between the user mode and the kernel mode, we are using what is called as mode bit. If the mode bit is 0, then you're in the kernel mode. If the mode bit is 1, that means you're in the user mode. Okay. So the diagram is explaining you, saying that from the user mode, if you're calling a system call. So system call is nothing but the functions which are associated with the kernel. That time what happens? Trap. Trap is nothing but an interrupt. Okay. Because of which you will be sent to the kernel mode. That time mode bit will be set to 0. Then once you complete the execution of the system call, you will be again written back to the user mode, wherein the mode bit is set to 1. That is about the dual mode. And the timer, what you're going to say, we want to avoid a situation wherein the user might enter into an infinite loop or never return the control back to the operating system. To avoid these kind of situation, we are using timers. So this timers can be fixed or variable. Fixed when you say, now our class, we say I should close the class at 11, so that is fixed. Whereas variable timers, wherein you're using a counter, initializing the counters to some value, you're initializing the counter to some value, and every time the clock ticks, the counter value will be decremented, and at one point of time when it reaches 0, an interrupt occurs and the control is again sent back to the operating system. So this is about timers. Are you clear with this operating system operations?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. Next, we'll go to process management. So, in the examination, you might get a question as, what are the functions of operating system? So, one of the function what you can write is process management. So, what do you mean by a process? So, you have the term program. So, I hope all of you know the meaning of a program. What do you mean by a program? Anybody?
Instructions.
Anybody? Yes. You have written some program and you have saved it, right? But the same program, when you're executing, then what you call it as? You can call it as a process.
Process.
Okay. a process is nothing but a program under execution. Okay, so you can say program as a passive entity, whereas process is an active entity because it is executing, right? So okay, so this process, it requires some resources to do the task. So what kind of resource? So what is process? Guys, what is process?
A program is in execution.
Execution. So program which is executing, so it requires some resource. Is it yes or no?
Yes, ma'am. Yes,
Yes.
ma'am.
Yes, it might require, or it will require CPU to do its task. It also requires memory as well as IO files. Yes. So all these files, either it can be given during the process creation, or in some cases when it is executing, that time it can be given. Okay. So that is about the resources that is received upon creation and along execution. So some cases it can be given during the creation of the process or when it is executing. And also initialization of data need to be done. That is any variables if you are using means it should be initialized, right? So all those things has to be done, and after that process will be executing. So once the process has completed its execution, then what should happen? Process has completed its execution. So for the process to execute, it requires resources. Once the resource is given, process will be executing. And once the process has completed its execution, that is nothing but process termination. So once a process has completed its execution, reclaim of any reusable resources. So any resource which the process has taken to execute, those resources should be reclaimed. Reclaimed by whom? Operating system should reclaim. Are you understanding what I'm saying?
Yes, ma'am.
Okay.
Yes,
Suppose
ma'am.
you say you are a word document is there. Okay, you have told it as print. You want to print that document. So what happens to print? What is the resource you require? What is the resource you require? Printer, right?
Printing.
Yes. So once the
Yes,
printing
ma'am.
job is completed, then what happens? That printer can be given to other processes. Yes or no?
Yes, ma'am.
Yes. That is what we are saying. Process termination means any resource what it was using, that will be reclaimed by the operating system, so that resource can be used by other processes. Okay. And next about single threaded process. So processes can be either single threaded, so thread is nothing but a single sequential flow of execution, you can say. Okay, or it can be multi-threaded. So about threads we are going to see in the later sessions. So in simple words, if you're saying, all of you, have you learnt about arrays and all?
Yes,
Anybody
ma'am.
who has not learnt
Yes,
about array?
ma'am.
Okay, suppose you want to add the elements of two array, then how are you going to add the elements of array? Are you adding like a0 element is added with b0 element and store the answer in c of 0? After that is done, then next a of 1 is added with b of 1 and store the answer in c of 1. Are you doing like this? Are you doing like this, guys?
No, ma'am.
Are you doing like this? And above all, you will be writing a for loop. In that for loop, you will be giving the value of the looping variable I is equal to 0, I less than n, I plus plus, you do like that, right? So that is for your single threaded process where one after the other you do. But whereas in case of multi-threaded process, what happens? You are creating multiple threads in your program. Only you are going to create multiple threads. So each thread will be doing, suppose the first thread is adding a0 with b0, next thread will be adding a1 with b1. Like this, everything can be done simultaneously. That happens in multi-threaded process. Okay. So in case of single threaded process, it will have only one program counter. So program counter is the one which is telling you the address from where the next instruction should execute. So in case of single threaded process, we have only one program counter, whereas in case of multi-threaded process, we are having one program counter per thread. Okay. So how you can say, I'll just show you in, I'll just open paint and show you. So what is the meaning of this? So I think so. Can you draw here? Okay. Are you getting the meaning of this single threaded and multi-threaded process, guys? Hello.
Yes, ma'am.
Okay.
Yes, ma'am. Yes, ma'am.
Okay. So about program counter is nothing but it will tell you from where you have to execute the next instruction. Okay. So in case of single threaded process, you will have only one program counter, whereas in case of multi-threaded process, you will be having one program counter for every thread. Okay. And next is about the activities, which is that is process management activities. So operating system is responsible for some of the activities which is associated with process management. So what are those activities? Operating system is responsible for creating and deleting both user and system processes. So user process and some related to the kernel, you can call it as system process. So operating system is responsible for creating a user process as well as kernel process, and also deleting a user process and the kernel processes. And also the next activity is suspending and resuming. What is the difference between deleting a user process and suspending a user process? What is the difference between two? Anybody? Guys, are you there?
Yes, ma'am.
What is the difference between deleting a user process and suspending a user process?
Deleting means is a permanently deleting.
Yes.
Temporarily. Okay.
Yes, temporarily, for time being, you're not allowing that process to execute, right? So that is also the responsibility of operating system. Next one is providing a mechanism for process synchronization. So with respect to process synchronization, you have an entire chapter related to that. So just example, if you're saying you have a program, that program you will divide into multiple threads. Okay. And you're making sure that all those threads are executed simultaneously. And once all the threads have completed their execution, that is synchronization, you can say, you're waiting for all the threads you're waiting for all the threads. Once after all the threads have completed, then you'll be going to the next step. Okay. So that is what happens in process synchronization. We'll be going to see in the next chapter. Next one is about process communication. So what do you mean by process communication? So it can happen that you have a process which needs to get some data from the other process. That is nothing but you can say process communication. That is, you might come across a situation wherein process needs to speak to each other. So that also responsible of your operating system. And the next one is scheduling process and threads. So which process should be executed at what time? All those things are the responsibility of the operating system. So this is what you have to tell with respect to process management. Okay. First of all, about process and program, you should say, and about the resource that is given to the process either during creation or during when it is executing. And once the process terminates, any reusable resource what you have, that should be given back. Okay, guys, I'll be back in 5 minutes. Please wait.
Okay, ma'am.
So that is about process management. Okay, next we'll come to the next topic, that is memory management. So again, this is a function of operating system. So when you say memory, do you have an infinite memory or is there some restriction with the memory?
Restriction.
Restriction with the memory, right? So you a process wants to execute. A process wants to execute means it requires memory also, right? If it is like you're storing everything in your main memory, then there might be some time wherein you'll run out of the memory space, right? So do you prefer such kind of task to happen? Yes, guys, am I audible?
Yes, ma'am.
Okay. So, memory, when you say memory is nothing but a large array of bytes where each of the bytes are having some address, right? Every memory byte will be having some address. So, CPU is going to read instructions from this main memory uh, whenever that is, you can say, during the fetch cycle. So, first, what happens? Instruction should be fetched, that is your instruction fetch cycle. So during that stage, what happens? CPU is going to read the instruction from the main memory, and after that, CPU reads and writes from the main memory during the data fetch. Okay, so even the data also need to be fetched. So all data and instruction should be transferred to the main memory in order to be processed as well as executed by the CPU. So once the processing, that is after the processing, data should be transferred to the memory. So once a process is terminated, then the memory space, whatever a process was using, that should be made available for other process. That is, when the process has completed its task, then whatever memory was allocated to that process should be freed, so that any other process that is requiring the memory, so that memory can be allotted to other process. Okay, so memory management helps to improve CPU utilization as well as computer response to multiple users by managing this memory needs among multiple processes. So when you say CPU utilization, optimizing CPU utilization, so what do you mean by optimizing CPU utilization? Means we are making sure that CPU is used efficiently. It is not like CPU is simply sitting idle without doing any task. So CPU is made busy. It is made to work with one or the other task. Okay, that is what we are saying. Optimizing CPU utilization and also computer response to users. So next one we are saying is about activities. So operating system is responsible for some of the activities which is related to memory management. So what are those activities? So keeping track of which parts of the memory are currently being used and by whom. So you need to keep track of the different locations of the memory, and which of them, which all parts are used and which are free. That is the thing that is keeping track, and which part of the memory is being used by whom, that information. Deciding which process and data to move into and out of the memory. So what can be the meaning of this? Deciding which process and data to move into and out of the memory. Now you're listening to this session. Are you listening to this session?
Yes, ma'am.
Yes or
Yes,
no?
ma'am. Yes, ma'am.
Okay. So even you have a memory, right? So your memory also should be managed efficiently. Yes or no?
Sure.
Yes. So you have to decide which of the data should be kept in and which should be removed out. Are you thinking of that now? Even you have, or even we have some memory restriction. It's not like you can keep everything in your memory, right? If you keep everything in your memory, then there might be one point of time where we'll be out of control. So whatever is required, only that we keep in our mind. What is not required, we'll just put it out, right? Same thing in computer also. We have to decide which process or data should be kept in the memory and which should be moved out. Moved out in the sense where you can keep, you take from the memory and where you can keep those data. You can keep it in some secondary storage device, right? Yes or no?
Sure. Yes, ma'am.
Yes. So that is also a task of your operating system. And finally, the last activity is allocating and deallocating memory space as needed. So either you allocate the memory space for any process, or you deallocate the memory space which was used by some process. So that is also the responsibility of your operating system. So these are the activities which the operating system is able to do with respect to memory management. Okay. Next topic is computer system architecture. So under this, we are going to see the different architectures, that is single processor, multiprocessor system and clustered system. So computer system may be organized in a number of different ways, which are categorized according to, the first one we'll see is single processor system. So when you say single processor, what do you mean by this? We have only one general purpose CPU, right? Which is going to execute all the general purpose instruction that is associated with the user or with the you can say system. So in case of single process system, how many? Only one general purpose CPU is there who is going to execute all the instructions. Okay. So systems may have other device specific processors, like for disk you are having a separate processor, or you can say keyboard, device specific. So these are called as device specific processors that can be there. So keyboard which cannot execute user process, that is not considered for your general purpose execution. These specific processes can execute only limited set of instructions. Okay. So under single process, what you're going to say? We are having only one general purpose CPU which is going to execute all the general purpose instructions, and you can also have device specific. Okay. That is device specific processors, like for disk you have a separate processor, but there is a restriction with that, that is it is going to execute only limited set of instructions. Okay. So OS cannot communicate with these device specific processes. They do work autonomously. Okay. Suppose we have a disk controlled microprocessor which will receive a sequence of requests from the CPU and implements its own disk queue. It will maintain its own queue as well as scheduling algorithm. So about the scheduling algorithm we are going to see in the next modules. So for time being, just remember these device specific process what you have, they're not going to communicate with the operating system. They do their own task. Okay. Thus CPU will be relieved from the disk scheduling work. So because of that, what happens, CPU will have its work reduced to some extent. Okay. So that is about the single processor system what we are going to say. Next one is about multiprocessor system. So in single processor, what did we say? We have only one general purpose CPU, right? So whereas in case CPU or processor, okay, single general purpose processor. Whereas in case of multiprocessor, what you can say, or you say this multiprocessor system, we can also call them as parallel system, or you can also call them as tightly coupled system. So these are the system which are having more than one CPU. Okay, whereas in single processor you said that we have only one general purpose processor or CPU, whereas in case of multiprocessor these are the system which are having more than one CPU in close communication, and they're going to share computers bus, memory, as well as peripheral devices. Okay, so these devices are, and even the clock cycles are also shared between all the CPUs. Okay, so communication takes place through the shared memory in this case. Okay, so we are also going to see what are the advantage of going in for multiprocessor system. So when you say multiprocessor, you have many processor which are going to execute your job. Then what about the throughput? What do you mean by throughput? Anybody? Throughput? Can you say it as the amount of work done, guys? Anybody?
Yes, ma'am.
Okay. So increased throughput is nothing but the amount of work done. Also, you can say it is increased if you're having multiple processor, and the economy of scale. So it will cost less than. So if you're having multiple processor, you're having multiple processor system, and you have single processor, but many single processor system. So when you say many single processor system, when you say single processor means you have only one general purpose processor, but that single processor system, when you say, it should have its own keyboard, it should have its own memory, it should have its own CPU, all those things, right? So instead of having multiple single processor system, it is better you go for multi processor system, because when you say multi processor, what happens? Only processors are more or CPUs are more, but what about other device? They are only one, right? Right, so for that purpose you're saying it is economy of scale. So multiprocessor will cost less compared to you having multiple single processor system, because when you're having multiple single processor system, then each of those single processor system, they require to have other peripheral devices, right? So that will cost you more. And the next thing you can say advantage, you can say it as increased reliability. So increased reliability in case of multiple processor system. Why? Because if one processor fails, will the system halt? In case of multi-processor system, if one of the processor is not working, will the system halt, guys?
No, ma'am.
No, right? It might, there might be some, or you can say it might slow down, but it is not like system will halt, because there are still other processors who are going to do the job, right? But whereas in case of single processor system, if that particular processor is failed, then your complete system is halt. So that is the advantage of going in for multi-processor system. The first one is increased throughput, next one is economy of scale, and next one is increased reliability. So under this, you will see just a term that is called as graceful degradation, and the next one is fault tolerant. Okay, so what is the meaning of this graceful degradation is, it is the ability to continue providing service proportional to the level of surviving hardware in the system. Okay, so what is the meaning of this? How much now multiprocessor system, suppose you have four processors, you assume. Okay, so out of that four processor, one processor is down, then what happens? Still there are three processor who are going to do the task, right? So that is, you're saying it is graceful degradation. That is, even though one processor is down, it is still having the ability to continue providing service proportional to the level of surviving hardware. That is, you still have three more processor working. So how much that three processor will work, using that it will still continue providing the service. Okay, that is called as graceful degradation. And the fault tolerant, that is, some system go beyond this graceful degradation, then you can call it as fault tolerant. because they can suffer a failure of any single component and still they can continue the operation. So that is the advantage in case of multiprocessor system. So under this multiprocessing, you have two types. One is called as asymmetric and next one is called as symmetric. So when you say asymmetric, in this case, each processor will be assigned a specific task. Either it can be predefined or it can be instructed by the master. Okay. So when you say each asymmetric, each of the processor will know what it has to do. Okay. It is not like somebody should tell them every time what they have to do. So each of the processor is assigned a specific task and it will be doing that task. So master processor schedules and allocates work to the slave processor. So you have the master and the slave relationship where the master will tell what each of the processors should do and those processor will be doing their allotted task. Okay. So this master slave relationship is very common in large systems. Whereas in case of symmetric multiprocessing, each processor run an identical copy of the operating system. So each of the, you can see here, each of the processor, they have register, they have cache, all those things. Okay. So in the first case, processors, n number of processors will be there and they will be doing their own task. We have the master here, one master who will be telling what the others have to do. Whereas in case of symmetric, each processor is going to run an identical copy of the operating system. You can say that all the processors are peers, okay, or a separate system. The benefit of going in for this model is that many processors can run simultaneously without causing any significant reduction in the performance. Okay, so that is an advantage. So most of the modern operating system are supporting symmetric multi-processing. Okay, so that is about your symmetric multi-processing. And the last one you have is clustered system. I'll just finish this and we'll wind up for today. The next one you have is clustered system. So clustered system, you can say as combination of multiple CPUs to accomplish some computational task. So cluster, what do you mean by cluster? Can you say it as a group? Yes. So clustered, that is a group which allows two or more system to share storage which are linked via the LAN. So the cluster system provide high availability, okay, and reliability also. Why? Because they are going to add level of redundancy. Redundancy means multiple copies. Okay. So again in this also you have two types. One is asymmetric and next one is symmetric. When you say asymmetric clustering, there is one machine which you call as a hot standby and others run that application. So if the active server is going to fail, then this hot standby machine what you are using, that will be the active one. Okay. So that is asymmetric. Whereas symmetric, you might be having n hosts and all those n hosts are running the application and monitoring each other. So all those hosts will be monitoring one another. If one fails, then other host is going to share that load of the failed host. Okay. So that is symmetric. Whereas in asymmetric, you are having a system called as hot standby. If the active server fails, then hot standby is going to do the task of the active server. Whereas in symmetric, every node or host will be monitoring the other one. If one fails, then the next one is going to do the task on behalf of the failed host. Okay. So that is about your operating system architecture. Okay. So we'll wind up for today. It's almost time.